introduce another industrial process which is called Haber process. So Haber process actually is a reaction for turning ammonia and hydrogen gas under certain conditions like 450 degrees Celsius and 200 atm with the presence of finely defined iron to produce ammonia gas. It is an exothermic reaction. So in this reaction, the raw material is air, and there's something what we call feedstock. So for feedstock is actually the industrial reactants that we use. For example, with the raw material air will actually be used to separate the air into nitrogen gas by fractional distillation of liquid air. So second, for hydrogen gas, it can be obtained by electrolysis of lime, cracking of petroleum, or steam methane reforming. For steam methane reforming is actually based on its name. It means that the reactant is steam and also methane to produce the hydrogen gas. So according to this reaction, methane reacts with steam. It will be used under certain conditions with catalysts to produce the hydrogen gas and carbon monoxide. If we would like to further maximize the production of hydrogen gas, we can also react the carbon monoxide with the water with the steam, which will also be used to produce carbon dioxide and hydrogen gas. So there will be more hydrogen gas being produced. And for the steam methane reforming is also a very important reaction that is used in another industrial process called methanol production. And hence, in this Haber process, ammonia gas is produced, which is very important to make chemical fertilizer such as ammonium nitrate and ammonium sulfate. The fertilizer acted to the soil to provide important nutrients to enhance healthy plant growth. So in order to make the healthy plant growth, there's some very important nutrients, and these very important nutrients are usually inorganic salts that contain one or more elements like nitrogen, phosphorus, and potassium, or in short, what we call NPK. And this slide is summarizing the industrial process of Haber process with different stations. First, nitrogen and hydrogen gas are mixed in the ratio 1:3 by volume. Why is it necessary to be 1:3 by volume? Is that based on the chemical equation of Haber process, you can see that the mole ratio of nitrogen gas and hydrogen gas is 1:3, and under the same molar volume, because gases will actually occupy the same volume in the same temperature and pressure. So if we can control the volume ratio to be 1:3, then the mole ratio of nitrogen and hydrogen gas will also be 1:3. Second, after the introduction of hydrogen and nitrogen gas, the gases will then be transferred to a station called purifier and dryer. And this part is actually help to remove any impurity from the inlet gas, such that it can avoid poisoning of the catalyst by sulfur or sulfur compounds. And after that, the clean and dry gas are sent to the compressor. The compressor is actually very obvious to compress the gas by applying very high pressure in 200 atm. After the gases are being compressed, they are then heated up to certain degrees Celsius and or sent to the catalytic chamber. In the catalytic chamber, it has the finely defined iron as a catalyst, and after the reaction, ammonia is produced. For the ammonia produced, it will then be cooled down and condensed to become liquid state. And after that, it will be stored in a storage tank. And for those unreacted nitrogen and hydrogen gas, they will then be used to recycle to the recycling pump. And in this chemical reaction, the heat released from the exothermic Haber process, that the heat will be used to preheat the nitrogen and hydrogen gas before they enter the catalytic chamber. So this also considering the environmental friendly, or such they can reduce the cost of heating up the nitrogen and hydrogen gas. And the ammonia is then liquefied under pressure in the condenser to collect in the storage tank. And after that, the unreacted nitrogen and hydrogen are recycled. So this is actually summarizing the key flow in the Haber process reaction. Next is about the economic consideration of Haber process. Why Haber process have such a lot of optimal temperature of pressure, or why iron is used, why the iron has to be finely divided. So let's take a look. First of all, why pressure have to be 200 atm? Because it is actually a balance for the yield of ammonia and the rate of reaction. So here is some explanation. You can freeze the video and take a look at the exact explanation. And why the temperature of the reaction is 450 degrees Celsius? It is also a balance between the rate and the yield of the reaction, and definitely of the cost of maintaining and constructing the equipment. So in order to balance the cost, the yield, and the rate of reaction, we do have the optimal pressure and optimal temperature to operate the Haber process. Next, why iron is used? Because iron is used as a catalyst. However, just something to remind that the use of catalyst will not affect the equilibrium position, or in other words, it will not affect the yield of the reaction, because it can only increase the rate of reaction, but not the yield of the reaction. So the yield of ammonia after using catalyst will still remain unchanged, but it will shorten the time to reach equilibrium. And last but not least, why the catalyst iron have to be finely divided? Because it can increase the surface area and hence increase the catalytic effect. Last but not least, for the products of Haber process ammonia, they can also be used for producing nitric acid by a catalytic oxidation, with these three chemical reactions happening. First, the ammonia from the Haber process will actually react with air under certain conditions, like 900 degrees Celsius, 8 atm, with the presence of platinum catalyst. It will produce the nitrogen monoxide and steam. And the nitrogen monoxide will then be oxidized to form nitrogen dioxide. And after that, the nitrogen dioxide will also absorb oxygen and water to produce nitric acid. So this is a very important chemical way to produce nitric acid industrially. So something please remark is that this part, platinum is used as a catalyst. You will also see platinum being a role of catalyst in some other chemical reaction. Also, ammonia can be used to make ammonium nitrate. So from the ammonia, it can react with nitric acid to produce ammonium nitrate. It can also be used to produce ammonium sulfate by reacting ammonia to sulfuric acid. And last but not least, ammonia can also be used to make urea. So here are some suggested HKDSE past paper you may look at and try to finish this part. So this is about Haber process. See you guys.